Hi there. Let's take a few minutes and review error types, and we'll look at some probabilities around those types also. So first of all, a type 1 error occurs when one rejects the null hypothesis when they shouldn't. And that's because the null hypothesis is actually true. So the probability of a type 1 error is the level of significance. That's also known as alpha. And the reason that the level of significance is the likelihood of a type 1 error is because a p-value, so when you run your test, a p-value below this level of significance is required in order to reject the null hypothesis, and you actually have to reject the null hypothesis in order to commit a type 1 error in the first place. So the level of significance, that value of alpha, that's the probability of a type 1 error. So a type 2 error is a little bit different. This occurs when one doesn't reject the null hypothesis when they should, because in fact the null hypothesis is false. They should have rejected the null hypothesis because the truth is within the alternative hypothesis. The probability of a type 2 error is more difficult to calculate. We could do it by hand, but it's not something that's important that you do by hand. It's more important that you look at patterns. What affects the likelihood of making a type 2 error, of not rejecting the null hypothesis when you should? So it will help if we look at a question in context here. So let mu equal the mean math SAT score for seniors in Hamilton County, much like we did on the front of this handout. So what's the probability of a type 2 error? That is known as beta. In the context of this test, the null hypothesis being mu equals 500 versus the alternative that the actual mean SAT math score for seniors in Hamilton County is more than 500. So let's assume that the standard deviation is 110 points. The sample size is 150 seniors, and the level of alpha is 0.05. So these are all things that we would need in order to do the significance test. So something to think about. Notice that to commit a type 2 error, we should not reject the null hypothesis when in fact we're supposed to. This means that the truth is within the alternative hypothesis. So something really important, beta, that's the probability of a type 2 error, has to be calculated for a specific value within the alternative hypothesis, because if we should be rejecting the null hypothesis but we didn't, that means the truth is actually within the alternative hypothesis. So we have to have an idea of where the truth is. So in this case, let's say that we want to make sure that our test is strong enough to reject the null hypothesis if in fact mu equals 525. So notice a mu value of 525 would definitely be within the alternative hypothesis. Oh, I just noticed a problem on my handout. That should be HA right there. There's the alternative hypothesis. So notice, in order to calculate the probability of not rejecting the null hypothesis, when in fact the actual value of mu is 525, so when in fact we should have rejected it because the alternative is actually where the truth is, to calculate that probability, we should run the power test program. So here's what that program looks like if we run it. So you want to press the program button. So down here, run the program power test. So select it and press enter. So the first thing you need to do is press enter again to actually execute the program. Now understand, you could do this for a proportion or you could do this for a mean. The question we're looking at right now involves a mean, so I will press 2 and press enter. So the first thing I have to specify is the value of the null hypothesis. So I'm going to move this up a little bit so that you can see it. There we go. So I'll check these off as we go. So the null hypothesis value was 500. So I have to specify that in the program first and press enter. So this is a one-tailed test. We could have done this for a two-tailed test, but it's a one-tailed test or a one-sided test because the alternative is strictly greater than. So I'll type in a 1 and press enter. So I have to give the calculator the standard deviation, that is the 110. I have to tell the program the sample size, that is the 150. And then after that, I have to give the calculator the level of alpha, the level at which we will reject the null hypothesis. So we'll enter that as 0.05. And after that, then finally, the last thing we have to do is give the calculator the alternative value that we are trying to calculate a type 2 error for. Again, remember, if a type 2 error has occurred, the truth is within the alternative hypothesis. So we have to tell the calculator where the truth is. Let's call it at 525. So the calculator will chug along just for a second. And here is the value of beta. You'll see that beta comes up as 0.13. So let's put that in here and talk about what this is. So notice 0.13, this is the probability of a type 2 error. Or in context, this is the probability of not rejecting the null hypothesis when we should have. And we should have rejected it because, in fact, the truth is mu equals 525, and that's within the alternative hypothesis. So this is another way of writing type 2 error. Notice that this probability, though, we have written in terms of a conditional probability because notice the condition is that the real value is 525. So what's the likelihood of not rejecting the null hypothesis when we should have under the condition that mu is really 525? That's 0.13. Now notice what the complement of this event is. Remember, to calculate the complement of an event, you take 1 minus the probability of that event. So 1 minus 0.13, that's 0.87. But notice what the complement actually means. Instead of not rejecting the null hypothesis, we do reject the null hypothesis when mu equals 525. So the likelihood of actually rejecting the null hypothesis when I should, because the actual value of mu is 525, that probability is 0.87. So rejecting HO when we should, meaning that our test result is correct. We should have rejected the null hypothesis because mu equals 525, that value right there, that value is within the alternative hypothesis. So this is known as the power, P-O-W-E-R. This is the power of the test against mu equals 525. So, and notice this was also given to us in the program. At some level, it's kind of silly that the program gives us both values. Here's the 0.87, here's the 0.13. These events are simply complements of one another. So beta, that's the probability of a type 2 error, the probability that we didn't reject when we should have. The power is then the probability that we do reject when we should. That's at about 87%. So understand, the power of a test tells us how likely are we to be correct? How likely are we to reject the null hypothesis when we're supposed to? And again, the power, just like the type 2 error probability, the power has to be calculated for a specific value within the alternative hypothesis. Because understand, if you've rejected the null hypothesis, then the truth must be within the alternative, so you have to pick what you think the truth might be. So when you are trying to determine the power of the test, then we always talk about the power against a particular alternative. In this case, that alternative was 525. So what's important here in this question, first of all, I want you to see the program is pretty easy to use because literally we just enter the different values that we would need to calculate the actual statistics test. We have to enter the null hypothesis value, whether the test is 1 or 2 sided or 1 or 2 tailed, the standard deviation, the sample size, the level of alpha, the alternative against which we want to test for a type 2 error or calculate the power. So understand then there are different making changes, if you will, to those values. And that's what I want you to recognize in practice question 3. changing specific values can change the power of a test. We would like to have more powerful tests, tests that are more powerful for detecting a value in the alternative hypothesis that we think is important. So notice this is what I'm going to ask you to use. I'm interested in seeing if you can recognize how to increase power, and at some level I've already given you the answer. So to increase power, you can increase the sample size. So I'm going to ask you to use the program and increase the sample size from 150 to 200 in the context of this question above that we've already done, and see what your new power is. Another thing that you could do is increase your level of significance from 0.05 to 0.1. So again, leave the sample size back to where it was supposed to be and just increase the level of significance. So the other thing that you could do is increase how extreme the alternative is. So instead of for finding power or finding the likelihood of a type 2 error against a value of 525, make it even greater, make it a value of 530. That's another way that you can increase the power of your test or simultaneously decrease the likelihood of a type 2 error. So try using the program. I want you to see that each of these results actually does what we expect. It actually increases the power. And calculating that by hand just is something I wouldn't expect you to do. I could show you how to do it if you are interested, but the truth is making this observation that these are strategies that can increase the power of your test, the likelihood of rejecting when you should reject, these ideas are what matter. So hope this has been helpful. Take care.